So in that first video that was the introduction to confidence intervals, we went through the whole process of a 95% confidence interval. And part of that process was finding a critical z-score that would help us capture that 95% of data between two values. And what we found there was a critical z-score of 1.96. Now, that part of the process and finding that critical z-score, it didn't use any of the data or information from the question itself. All that came from was that we were looking for a 95% confidence interval. And what that means is that for the rest of this class, whenever I ask for a 95% confidence interval, that means your critical z-score is 1.96. So we're going to find values here also for 99%, 90%, 80%, because those are going to be our most commonly used ones. And I'll show you the process, but once we find them here, you don't need to go find them again. You can just kind of keep this little guide sheet of, if you're making a 99% confidence interval, grab the z-score here, because that won't be determined by any other information in the question. Now, I like to go through this process rather than just giving you the four numbers and moving on through there, because it could happen where someone asks you for a 92% confidence interval or 87% confidence interval, which is a very rare case. I would say 95% of the time, 99% of the time, you'll be using the numbers right here on this sheet. But I want to show you the process for that 5 or 1% of the time that you might be asked a question using a different confidence level, and then you'll know how to find the critical z-score no matter what. Okay, so let's start with our 99% confidence interval. So these are z-scores, so all of these are going to use the standard normal distribution. And what I'm going to do is draw my bell-shaped curve here. And since it's a 99% confidence interval, I want to divide this up so that I have 99% of the information in between two cutoff values. So again, this is going to be centered at 0. And what I'm going to do is look for my critical z-score off to the right here. You could also use that value on the left. It's just a difference of negative versus positive. But finding that critical z-score, that's where I'm going to go to Stapplet. So I'm going to go to normal distribution. I know the area under the curve, so I want to calculate a value. Mean of 0, standard deviation 1. And this is going to be a central area of 99%, so 0.99. And that's a 2.5758. Be sure to go to at least 4 decimal places here if you can. Some of these are going to round a bit, so you won't see all 4 decimal places, but we want to keep that accuracy and not round too much at the beginning. 95% we've actually already done, but just to kind of go through the process again, we have our bell-shaped curve. We're having a slightly smaller area with 0.95 in the middle, and we want that critical z-score off to the right there. So what would change is just in Stapplet, I would switch that 0.99 to 0.95. And that's our 1.96 that we saw before. So it didn't change. And this is only going to have 2 decimal places to it. It rounds nicely to that. Okay, the 90% confidence, same process, but now we're going to have 0.9 in the middle. So I want that critical z-score. So in Stapplet, all I'm going to do is change that area to 0.9, which is a 1.6449. And then for 80%, same process, but now we have even smaller area with 0.8. And finding that critical z-score off to the right there. So I'm just going to change my area to 0.8, and we get a 1.2816. So I would keep this piece of paper or even just like a little sticky note with 99% confidence, z-star is 2.5758, and just have those written down so it's easy to find as you work through these problems, so you don't have to recreate that process each time. But then just know, no matter what confidence level they give you, if it's not on this sheet or if you don't remember what they are. You can find it by set up that standard normal curve and set that percentage as the area that's central underneath that curve, and the cutoff will give you your critical z-score.